Nevada Virtual Academy, welcome back, Mr. N. Let's do some factorization, and you're asked to factor this trinomial if possible, right? And you know, I'm always checking to see if this trinomial could be factored before I'm doing anything. If this will be a test for me, instead of trying to um, you know destroy myself or to go nuts and trying all the possibilities and combinations here to see if this one is a factorable one. I'm just going to look for the discriminant. If this 3h squared plus 2h minus 16 will be an equation, a second degree equation. You guys remember that the standard form is what? Ax squared plus bx plus c equals 0, right? Well, if this is, a quadratic equation, then you should identify your A, your B, and your C, which are what? What is your A? Well, A is the coefficient of your quadratic term, which is what? 3 in this case. What is your B? Well, B is the coefficient of the first degree term, which is 2. And what is your C? The free term, the number. Make sure you're taking the sign that's in front of it. That's negative 16. Okay. Next step. Find your discriminant, which is b squared minus 4ac. And this one equals what? B squared, 4 minus 4 times a, 3 times c, which is negative 16. This one equals what? Well, I have 4 minus 4 times minus right there, negative negative will be positive, plus 4 times 3 times 16. And I basically have what? I have 3 times 16, which is 48, multiplied by 4. 4 times a is going to be 32. 4 times 4 is going to be 16, plus 3, 19, and will be 192, right? I hope I got it right. 4 times 8 is 32. 4 times 4 is 16, plus 3, 19. Okay, so I have 192, which equals 4 plus 192 is 196. And we know this one is a perfect square, which means, and the main thing I'm looking for is this greater than or equal to 0? Hold on. Is that greater than 0 or equal to 0? Yes, which means I have two solutions to this equation, which means this trinomial here is factorable. Now let's see ways to factor this one out. I'm going to check the first and the last one, right? Because if this is factorable, I will have two binomials in which the first term is going to be a factor of 3h squared, and I suppose it's going to be 3h or h if not. And the second one, what other number multiplied by 3h is giving me 3h squared? H, right? Because 3h times h gives me the 3h squared. Now for the last one, because I have a negative sign in here, I'm not sure. I'm confused yet. I'm looking for it. Where is going to be? Because I should definitely have a negative in the positive term, although their sum, the sum of the first degree terms will be positive 2h. I'm still not sure if negative will go in here or in there. And that should take me to the next step. Next step, you're looking for factors of 3. Factors of 3, we have what? 3 and 1, right? We also have 3, negative 3 and negative 1, and obviously taking them backwards, will have the same thing. And I have also to look for factors of negative 16. Factors of negative 16, let's see, negative 1 and 16, negative 2 and 8, negative 4 and 4, negative 8 and 2. And it looks like I'm going backwards. You can go with negative 16 and 1, right? Good. Now I'm thinking about, well, if this one here is going to be 3h, right? I have to find which coefficient or number, if you want, will go here as the last one in such a way that when I'm multiplying this one by the last term here, I'm going with the FOIL, and I got the first terms, which is already here, is going to be 3h squared, right? And then I'm going with the outer terms. I have 3h times, let's say if I have 3h times negative 1, basically 3, I'm just using 3. 3 times, why I put negative 3? 3 times negative 1, to which I will add the product of the inner terms, right? Because I'm going FOIL. First, outer, inner. Here in the inner term, because I use 1, I use negative 1 for this one here, right? Negative 1. I have to put what is, the number that multiplied to negative 1 will give you negative 16. That's 16, right? Will be positive 16. And I'm looking to see, is it, I use the 3 from here, right? And now if I'm using 1, 16 times 1, is it negative 3 times, 3 times negative 1 plus 1 times 16 going to be equal to what? To this 2? Well, I don't think so. You guys can see, right? Negative 3. 3 times negative 1 is negative 3 plus 16 is going to be 13. So this one is not good. I cannot use this combination, right? So let's try the other one. Or if you want, you can try backwards. How about putting 16 in here and see that? But, if you think about 3 times 16 is going to be 48. And then I will have 1 times h, which is negative h, 48h plus minus h is not going to be 2. So that one is not working, and I can even take this pair out because it's not going to work for me. I'm going to take the next one. How about grouping this 3 or multiplying this 3 with this negative 2 from here, right? Which that negative 2 will be placed in there, and then using this 8 as the second term in the first parentheses. I don't know. Let's see if it's working. I have 3 times 3 times negative 2 plus 8 times 1, right? And I have 3 times negative 2 is going to be negative 6 plus 8 equals 2. And I think we got it, right? It looks like this is the way. This is the combination of the second terms that works for my trinomial here. Because now, just try the FOIL. If I will go with the FOIL, I have what? 3h times h, which is 3h squared. 3h times negative 2 will be negative 6h. 8 times h is going to be positive 8h. 8 times negative 2 is going to be negative 16. Negative 6h plus 8h will take me right here. I will have the middle term. Everything else works. This is the answer. Okay? And that's how you factor this given trinomial. Like I said, I will always try to see if that's not a prime. Because if that would be a prime, imagine you have to check every one of these pairs in here, and sometimes you may have, 20 of them. It will take you forever when you can actually just go and check to see if your delta is greater than 0. Because if it's not greater than 0, then that trinomial is a prime one. Okay. Now, if you don't remember how to do this method by the factors of the first and the last term, you can always use the quadratic formula. And after we found delta and we said delta is 196, you can go ahead and find your two roots, right? Which your two roots are what? What is the formula? Negative b plus minus square root of your delta, which is square root of b squared minus 4ac over 2a. And I'll plug in everything that you know. And I know my b is 2, right? That's your b. So it'll be negative 2 plus or minus square root of 196, because that's our delta, is right here, 196 over 2 times a over 2 times 3. This one equals what? Negative 2 plus or minus square root of 196 is nothing else but what? 14 over 6, and you have two possibilities. Negative 2 minus 14 is going to be negative 16 over 6, right? Negative 2 plus 14 is going to be 12 over 6. Well, 12 over 6, we know that's what? 2. 16 over 6, I can simplify by 2, and that will give me negative 8 over 3. Okay? So now, you basically have two equations. One of your roots equals negative 8 over 3. The other root equals 2. And if you want to change them into an expression in x plus or minus something equals 0, right? going back to the fact that you have an equation here, I can add 8 thirds, right, to both sides, subtract the 2 in this case here. And what you have? Well, from the first one, you will have x plus 8 over 3, right? And from the second one here, I will have x minus 2. Well, this one equals 0, this one equals 0. But these are basically your factors, right? So your trinomial could be written as what? X plus 8 over 3 times x minus 2, okay? But I don't want to have denominator in here, and because all of this was equal to 0, you can multiply by 3, and you have what? You have 3x. I'm multiplying by 3 just this in the right side, because that 3, you know, if you put that 3 in here, will be multiplied by x and by 8 over 3. So this parenthesis will have what? 3x plus 8. In the second parenthesis will be x minus 2. What do you guys notice? It's the same thing, right? The same thing like here. I just use a different approach. Like I said, sometimes you may not figure out, not be able to find, you know, whatever combinations of factors you have in here. And this quadratic formula is always, you know, these two, that one, the discriminant, and this one are always helpful to save you if by any reason you have a blockage and you cannot see which way you can factor this. Well, this is it. I hope you got it, right? Or we'll do more. Just hang in there. Thank you.